Welcome. Raw data is kind of like a giant box of puzzle pieces, right? Each individual piece holds a tiny bit of information, but by itself, it doesn't really tell you much. The real magic, the real story, happens when you start connecting them. So today, we're going to open up the Data Architect's Toolkit and show you exactly how to assemble those pieces to see the full picture. So what's the secret? How do we take all these separate tables, one for employees, another for departments, maybe one for projects, and weave them together to answer the really interesting questions? Well, that is exactly the challenge we're going to tackle today. Let's jump in with the very first and maybe most important tool in the kit. Before we can even think about building something cool, we need to make sure our foundation is rock solid. And in the world of data, that foundation is all about trust. So the first tools we're going to look at are the guardians, the rules that protect our data's integrity and make sure it's reliable right from the get-go. And that foundation has a name: data integrity. Think of it like a set of non-negotiable, hard and fast rules for your database. It's not just a friendly suggestion, it's more like a bouncer at a club that actively stops bad or inconsistent data from ever getting past the velvet rope. Every great data story is built right on top of this. Now, data integrity basically stands on four main pillars. First up, entity integrity. This just means every single row is unique. No two employees can have the same employee ID. Simple. Second, referential integrity makes sure all the relationships actually make sense. You can't assign an employee to a department that doesn't exist. Third, domain integrity checks if the values themselves are valid, like making sure an email column actually looks like an email. And finally, you have user-defined integrity, which is for any custom business rules you might have. Okay, let's zoom in on that third one, domain integrity, because one of its rules, the unique constraint, has a really fascinating secret. Now, it's supposed to do one simple thing: make sure every value in a column is different. Sounds straightforward, right? Well, it gets a little weird when you're dealing with missing information. Okay, so this is where it gets a little mind-bending. You apply a unique constraint to a column. Then you insert a null value, which just means the value is unknown, and yep, the database takes it, no problem. But then you try to insert a second null value, and it works too. Wait, what? How is that possible? How can a supposedly unique column have two of what looks like the same thing? The whole secret to this puzzle is understanding what null actually is. It's not the number 0, and it's not an empty text field. Null literally means a value is not known. It is a placeholder for a complete absence of information. And that's the brilliant little piece of logic right there. Since the database sees null as, I don't know, it can't prove that one I don't know value is equal to another I don't know value. So they aren't treated as duplicates. The integrity rule isn't broken, it's just being interpreted with this really clever twist. All right, so our data is safe and sound. Now let's grab a tool that's all about making our lives easier by tidying up our code. Let's talk about aliases. Just look at this before and after. It's night and day, right? On the left, our code is long, it's repetitive, it's kind of hard to read. But on the right, we use aliases to create these simple little shortcuts. The employees table just becomes E, and we can even rename full_name to name to make the output clearer. It's the exact same query, but it's so much cleaner and way easier to understand with just a quick glance. Okay, our code is clean, our data is solid. Now we get to the real fun part, connecting everything. This is where we actually start building our story, using the most important connectors in our entire toolkit, the joins. First up is the workhorse, the one you'll use all the time, the inner join. The easiest way to think about this is like a Venn diagram. It only shows you the data that exists in that perfect overlapping section, the records that have a direct, confirmed match in both tables you're joining. If an employee isn't in a department, they're not going to show up. It's all about those perfect connections. But what happens when you need to see everything from one table, even the lonely records that don't have a match in the other? That's what left and right joins are for. A left join basically says, hey, give me every single record from the table on the left, and just bring along whatever matching data you can find from the right. A right join does the exact same thing, but for the table on the right. In short, one side is the boss. All right, so those are your everyday tools. But every now and then, you run into a problem that needs something a little more specialized. Let's get into the power tools for those really tricky situations. Now, here's a great little insider trick.
You see, MySQL doesn't actually have a built-in full join, which is what you'd use to see all records from both tables, whether they have a match or not. But we can build our own. You just do a left join, then you do a right join, and then you use an operator called union to stitch those two results together. It is a really clever and powerful workaround.
Okay, let's switch gears to something wild. What if you didn't want to find matches at all? What if you wanted to generate every single possible combination between two sets of data? Well, for that, you've got the cross-join. It doesn't look for any connecting keys, it just pairs every row from the first table with every row from the second. So, to put some numbers on that, imagine this. You have a table with 5 employees and another with 3 departments. A cross-join will spit out a result with 15 rows. It literally pairs each of those 5 employees with each of the 3 departments. This is called a Cartesian product. You have to be a little careful with it, but it's incredibly powerful when you need to generate all possible pairings. And for our last power tool, we have something that sounds a bit strange at first, the self-join. This is for a really specific but very common problem, when the relationships you need to map exist inside of a single table. So the big question is, how and why would you join a table to itself? The perfect way to think about this is a company's org chart. An employee and their manager are both, well, employees, right? So they both live in the exact same employees table. A self-join is the magic trick that lets us pretend that one table is actually 2 different tables, one for the employees and one for the managers, so we can connect them and map out the entire company structure. You know, up to this point, all our joins have been about connecting data horizontally, side by side. But what if you need to stack your results vertically, one on top of the other? For that, we need the final tool in our kit. And this brings us to a classic choice, union or union all. Think of it this way. Union is the smart but slower option. It combines your results, but it also does the extra work of automatically removing any duplicate rows and sorting the final output. Union all is the fast option. It just smashes the results together, duplicate, sorting, and all. So if you know you don't have duplicates or you just don't care about them, union all is always going to be faster. And there it is, your complete Data Architect Starter Toolkit. We've got our guardians to keep our data trustworthy, our cleaners to make code readable, the basic connectors for everyday relationships, our power tools for those tricky hierarchies and combinations, and finally, our combiners to stack results. So with these tools in your belt, you're not just looking at isolated data anymore. You're an architect, and you're ready to build complex, insightful, and really powerful stories from that data. The only question left is, which one are you going to build first?